All right, welcome to this week's Istio working group meeting. If you have any agendas, please add to the meeting notes. I'm seeing two things on the agenda from last week. John, you want to kick it off with KRT?
Yeah, so the only thing we have is Jackie here. No, okay, I guess that's one thing we want to talk about. Let me pull up the PR. So I've been doing some effort to migrate the API controller to KRT and have it fully passing all the tests, working end to end, and I think pretty much ready to go. It's a large PR, and outside of the actual code change itself, it's also kind of a first or step for the project. So I wanted to bring it up here to get some general direction and feedback and whatnot on what we want to do here. I put the link in the chat of the, let me put it in the notes as well. Someone did, thank you. So yeah, that's it. I can walk through it, or I don't know what would be useful for people, or if they have no idea what I'm talking about and I need to provide a lot more context.
Yeah, question, do you notice the improvements after moving to KRT? What are the type of improvements did you notice, if there's any?
Yeah, so the PR has a picture of a description, basically, where I did a test before and after with some, heavy load, and shows quite a bit of improvement in the consumption of the control plane. It's kind of an interesting one because one of the goals of KRT was largely actually about improving, like making the code easier to write. It was kind of two parts. It was one, to make it easier to write, but also then to be efficient in terms of like what events we propagate downstream. The old gateway API controller was interesting because it actually was even easier probably to write than KRT, because the way it worked was that any change that would happen, it would recompute the entire world. And so there was no, like normally the problem with controllers is we go and it's like, okay, we got this event and now what of these 20 indexes do I go and update? There wasn't actually that much of that in the gateway controller, because it was more like, okay, one gateway changed, I'm going to go recompute all the gateways and then recompute all the routes. And then I'm going to send an event that says, hey, everything changed to Istio. So it was trading off being very easy to write and understand for efficiency, and that any change recomputed everything. Which is different than basically every single other controller in Istio, which if we did a good job and rewrote in KRT would hopefully be quite a bit simpler. So what we see here is really just in performance improvements, because when one route changes, we just change that route basically, and we don't have to go recompute the entire world. Yeah, Costin.
That's, I mean, gateway is the main reason we have this complexity in everywhere else. I mean, for sidecars versus gateway was that we have very few gateways, and sometimes it's easier to just throw away everything. But unfortunately, we never throw away, because with the way Kubernetes works, it's kind of, it keeps a copy anyway in memory, so it's not really, it didn't really work as expected or as intended.
Yeah, and this is also used for mesh now, since it's HTTP routes for mesh. So
yes, now the original. So when we did the first discussion about scalability and everything else, we had the distinction between what we do for computing routes configurations and other things, and the EDS data path, which was kind of optimized separately and had slightly different behavior.
Yeah.
Do we still have that with the KRT? I mean, do we still have the properties that endpoints go fast and bypass pretty much everything?
We do, yeah. So
okay.
Yes. So all of this lives kind of on top of that layer. Basically, there's still the same abstraction of like I think it's called a config controller, and we still implement that. And so the difference really would be that before, let's say HTTP route changes, before it would go into the gateway controller, recompute all the HTTP routes and convert them to virtual services, and then push context would initialize and read that. Now the same thing happens. HTTP route changes. We go and change just that one virtual service that changed, and then the push context will still read it all.
As long as endpoints go fast.
Yeah, and endpoints still bypass the whole thing. Like
Okay,
there is a
that's
lot further we could go in theory of like, hey, maybe we don't need to recompute push context, but that's way outside of the scope of this.
Yeah.
It would be quite hard.
And the other comment I had about this KRT, which is a very nice piece of code. My concern is that it's a very Istio specific, very tightly coupled with Istio. Nobody else outside of Istio is using it. It would be a perfect candidate to, kind of move to a standalone project, either an ecosystem and see if, because it's, small universe though. I mean, with the number of Istio contributors, and if it's that useful, probably other people would benefit from it, and they cannot take it with the whole Istio dependency.
Yeah, there are some other projects that are using it and importing the whole Istio dependency, which is painful, obviously. So I don't disagree with you. Though there's two reasons, and it's not to say we shouldn't do it necessarily, but the two reasons why we haven't done it today, other than that it takes some effort to do, is there are some imports on like internal Istio stuff, like our logging package or our sets package, all the stuff that doesn't necessarily need to be there, but it is. And then there's also,
which is a perfect opportunity to move them as well and maybe move to Slog.
Yes, I agree. And then there's also just what am I missing? Oh, just like then we have two repos. So if I want to go make a change, I have to go, split it out. It's the whole standard stuff. So it still may be useful to do. That's just why it hasn't been done yet.
Yeah, I wouldn't say it's a red package, but kind of, if we want to have modular packages, and that's a benefit that you have to modify both, because you can have versioning and it's far more. Anyway, so that was my comment, and I think it's well worth doing it if we want to especially if someone is already using KRT.
Yeah, it would be a waste of time, I think, if we split out and then no one used it. And the people who are using it today are able to use it. But if there's other people that also want to use it, then it'd probably be worth the effort, I think.
Yes, and if I'm reading your comments correctly, it's not a blocking on this PR. Sorry, I think somebody else was also trying to weigh in.
I was just going to mention that from a K gateway context, even if it was separate, we would still take a dependency on Istio. So for us, it's not a big deal, I think, either way.
Yeah. Yeah, thanks for that context. Now, I have a questions on the graph, just making sure I'm reading it correctly. I know you mentioned about like the first part of the time is this PR, the second part is master, which I assume is without this PR. But how do I, so I assume the instance of the Istio, I should ignore it. That's irrelevant to link to which with the PR or without the PR, I should just read by like this memory. And
yeah, that was just, there happened to be two instances because of some stale state from some other test I was doing or something like that, I think.
Okay, so from a data plane perspective, it's clear like the first half is lower, right? Which lower is good. Now, from a memory perspective, how do I read this? Because there are multiple instances.
Yeah, so the orange one is this PR and the blue one is master. So there is some increase in memory.
Okay, so only the memory has some increase, but the CPU and the memory of the data plane is definitely lower.
Yeah, the reason why the data plane's lower is because we have less pushes, so it has less work to do.
Yeah, that makes a lot of sense. No, you don't have K gateway number any chance. It's just
I have them. They're not in this picture though.
Okay. Okay, makes sense.
I want to ask, is that a general K gateway characteristic as far as the CPU memory trade-off?
Do you mean KRT?
Sorry. Yes, you're right. Too many acronyms.
It's a good question. I'd say maybe. It depends. I think for other controllers, you wouldn't see as much or any increase. The gateway controller was kind of special in that it didn't really need to do any, like it didn't store any intermediate state at all. And
Right.
So it was really trading off like zero caching, basically.
We're just pushing pretty frequently, I'm guessing.
Right, like any change, you recompute everything. So
yeah,
obviously there's always a trade-off in things that can be recomputed with memory and CPU. This test is, I think, like 5,000 routes or something. So it's quite a large amount of routes. In practice, and then like one pod. So in practice, you're probably going to have more pods in the real world. In which case, like the scales of this are going to be quite a bit different. Like you'll have 200 extra megabytes, yes, but your Istio is already probably using like 5 gigabytes or something. And then the CPU amount scales more with the number of connected XGS instances, so you probably see even more benefits at a more realistic cluster scale.
Yeah, okay, thanks. That makes perfect sense.
So in your test, it's just one gateway and one Istio pod.
Yeah, there's one gateway pod, one Istio pod, and then we just create like 5,000 routes very quickly or something along those lines.
Okay, got it. By the way, I assume this is a customer dashboard tool that you aggregate the memory CPU together?
Yeah, I just put a quick dashboard together, getting the memory and CPU of the control plane and data plane, and was comparing to some other implementations. So that's why you see the other one up there.
Yeah, makes sense. Thank you.
Anything else we want to discuss here?
No, if you make this change, would this move the waypoint as well, I assume?
The waypoint consumes the output of this, so it would impact the waypoint as well. In terms of like these 5,000 routes are currently targeting a gateway, but they could just as easily be targeting a waypoint. And then you'd see the same difference for 5,000 waypoint routes as 5,000 gateway routes.
Yeah, so the gateway API controller, if you migrate to KRT, I guess my question is that would also migrate the waypoint, or there's additional work for the waypoint control?
No, it's all, there's one thing that controls gateway API, so HTTP routes, gateway, TCP route, all that sort of stuff. For whether it's for sidecars, waypoints, or gateway, it's all shared logic. So this would be impacting all of them.
Okay, cool.
Okay, I take this as a sign that there's no high-level objection or questions remaining, and I will, it's currently in draft, it's not quite ready to go, but it probably will be by maybe the end of the day, so I'll go and get some people to actually review it and go from there. Thanks.
All right, thank you so much, John. Do we have Jackie on the line?
Yeah, I think we got to this last time.
Yeah, do you want to talk a little bit more, or there's enough from last time?
No, I think I'm going to bring it up with the product security working group. We have a meeting today, so I'll bring it up there. I need to do more investigation into, how much work this would be to support. But yeah, I'm still very interested in pursuing this. I just need to bring it up with the product security working group to see if that's something we're interested in supporting.
All right, sounds good.
Yeah, thank you
So much, Jackie. Keith, I think you have another topic you may just added.
Yeah, John's KRT topic reminded me of the KRT stuff I've been looking at. Let me link the PR. So this is related to some of the multi-cluster stuff as we start talking about implementation. Right now, all the collections in KRT are static, meaning that, or rather the joined collections in KRT are static, so you can't sort of have a set of collections where the elements, the number of collections within that collection change throughout the lifetime of the program. Had some great early feedback from John and Ian on this and sort of on how to implement this. So dynamic joining, with the idea being that the number of clusters that IstioD reads can change throughout the lifetime of IstioD. And so this PR adds that functionality. Some stuff is still in progress, getting some of the kinks out. But the thing I wanted people's feedback on, Lynn, if you want to scroll down a little bit down to the bottom, there are two APIs that are sort of up for discussion. That last comment that I sent right there. So there are, actually, that's not a great one. Maybe, oh, it's on the other PR. John had a John had a comment in another PR proposing the different implementations. Let me link that in the, all right, one's in draft and one's in open, so I missed it. Apologies. Yeah, so basically the question between two different interfaces. One is sort of an imperative interface. That's what I implemented initially, where you create a KRT collection, and then you can add and remove collections from this dynamic collection imperatively via an API. John had a really cool idea of instead of doing this dynamic imperative API, what if it was more implicit and the user passed in a collection of collections? And I did some early POCs of it, and it looks like it's viable with some small changes, maybe a little bit of black magic. We'll see. But I wanted to sort of get people's, well, I've got already here, see if people had a preference for which API felt more ergonomic, so to speak.
So like the collections themselves would count as an input that you would kind of track as state, and you recompute when that changes.
Exactly. Some of the event handling gets a little weird, but by and large, I was able to get something working with that second approach.
Sounds cool to me.
Yeah, like for example, with this approach, you could have a collection of secrets and then translate those into cube configs, and then translate those into collections, and then join those or something. Honestly,
that's what I said in Slack. I really liked that approach.
I don't fully know if the way we have things structured in Istio today, given that we're taking old code and slapping new things on it, if it's actually going to work out end to end, but it would at least allow you to do that.
Yeah, agreed. And the static and singleton KRT helpers get us part of the way there, I think. But sounds like generally, Stephen thought it was cool. John likes the dynamic approach, the nested dynamic approach. So might go with that, unless folks, anybody really want to imperative API.
I didn't get a chance to look at it too closely yet, but I seem to recall you mentioning that there were some like downsides in terms of, oh yeah, right there, when we remove things, how those events propagate. Do we think those are like something we can deal with?
I figured out a way around it. So in my first pass implementing that nested join API, where it's just a collection of collections, the way I implemented it, like sort of tried to use collections all the way down. Your indexes were like collections of like synchro interfaces, and it allowed for no locks in the nested join implementation, but I did come across some data races when I was running the unit tests. So there is some shared state when it for the nested join implementation, specifically for the whenever a collection is added or removed, I sort of link up event handling to propagate that event all the way down to the inner data, the inner data objects within each one of the collections. So there is some state as we let that slice change dynamically. But aside from that, the two implementations are identical as far as capabilities, and I've written some tests to validate that. That I haven't quite. I pushed them up a little bit earlier today. So no more trade-offs. They're the exact same. It's a question of interface at this point.
Nice. Thanks.
No problem. I got my direction and answer. Appreciate everybody.
All right, very good. Do we have any other topics? Or should
I can talk a bit if nobody has anything else to get some people's opinions.
do you want to present yourself?
Yeah. No. I think I can just. Maybe I will present. I'm not super ready to, but. Am I presenting? Oh no, I'm not. Present. Okay, that looks good. So I'm looking at the double H phone right now. And wait, it's showing that it's muted. Can somebody talk?
I can hear you.
Okay,
We
okay.
can see you. Yeah, we can see your browser now.
Okay, good. And there were a few things that we can talk about if nobody has anything else. The first one is actually let's talk about the here. So this was about the multi-cluster XCS API and how we interpret it. So right now we only have one one protocol for cross-cluster traffic or multi-cluster traffic, and that's double H phone. And the question is, and John made a comment in my PR saying that, hey, maybe the East West Gateway doesn't support H phone or this and that, right? And I guess my question is, right now in the workload, there's only one protocol field, and should we add another protocol field to the network gateway field, if that makes sense?
I think the information the control plane provides today should be sufficient to implement the cross network in zTunnel. We know that when we're connecting to a network gateway, we should always use double H phone.
Okay, so if there's a network gateway, use double H phone.
Yes.
Okay. Okay. And then the other thing I kind of wanted to bring up is in zTunnel, we kind of check our sizes between. But these numbers, like the size of the size of the future can change based on like compiler optimizations. And it kind of feels like this is a bit of a red herring.
It's not really. Like, I think you said somewhere that you were getting it as like 8,000 bytes or whatever. Like, that's exactly what the test is supposed to catch. Because what that's saying is that this PR makes this so that instead of every connection using 1.7 kilobytes of memory in RAM, it's going to use 8 kilobytes, which is going to quadruple the CPU or the memory usage of zTunnel.
Yeah, but if I like build it in release mode, then it goes back down. I
think that happens today. But it's either it doesn't happen today or we don't check
We
that
build
in
it.
release mode. I think we don't check it. Yeah, we don't panic if it's if you're in debug mode. It's how the function is defined.
Oh, really?
At least that's a 10. Like I'm looking at the code and it has a different implementation if you're in debug mode or not. And in debug mode, it does nothing.
Okay, perfect. I'll look into that.
Yeah, I mean, if you're seeing issues, it might be that that logic is wrong. It looks a little complicated. It could be wrong, but it's not supposed to panic. Yeah.
Okay.
But in release mode, using too much, then it's probably a real bug, and it to fix sometimes because it's kind of opaque why it's large sometimes. That I can help you. There's a little comment on there. It looks like, but it's I don't know if it's not enough. Let me know. I can help. I've spent a lot of time on this and didn't want to, which is why we added the test because we used to be using like 15 kilobytes per connection, which is obviously quite terrible.
Yeah. Okay. Awesome. Keep.
One of the interesting things, as we were talking about this a little bit internally, is that Stephen, am I remembering correctly that the way that you got the number down was to just box pin the function?
Yeah.
The feature?
Yeah, and that happens in other places too.
Okay. I go ahead. Sorry.
Oh, I was just gonna say, like, at first glance, it seems kind of like, oh, you just traded stack space for heap space, but maybe it makes sense if it's like allocating dynamically.
That was gonna be my question. Do we have a sense for whether or not stack allocation versus heap allocation makes a meaningful difference for the connection logic in tunnel?
So the issue is that if you, let's say you don't pin anything or you don't box anything, which means it's all in the stack. How Rust futures work is it's going to take the worst possible stack size of all the possible paths, and it's going to use that no matter what. Let's say I had like let's say the network path was like massive for some reason. It probably isn't, but let's just say it was. But we rarely take that, right? If we put it on the heap, then sure, we'll pay that cost on the heap when we take that path, but we're not going to pay it for every single connection.
Okay.
Gotcha. Okay. So it's a fork of the Rust compiler and how it allocates stack sizing. That's really good to know. Might be good to add that to the, well, I think it actually already is in that comment, but maybe a comment near the actual connection logic might be helpful because I didn't put that together.
It's in the size between ref comment. It says something like future size is determined by the max required stack size.
Got it. Okay, thank you.
Yep. It's very strange, kind of, but I mean, it makes sense, but it's not intuitive if you're not familiar with the internals of how async and Rust works. So.
Okay, perfect. That helps me a lot. Thank you.
Oh wait, are we good? Should we wrap this up? All right, I'm not hearing any other topics. Thank you so much, everyone, for joining. See you next time. Bye.
Thanks, everyone.
Thanks. Cheers.